Hi girls, we're taking a bit of a look at differentiation of trig functions. But first, there's Bailey eating her first bone. Okay, so up in the corner, left-hand corner, I've got the basic derivatives. Sine of x, derivative cos of x. Cos of x, derivative negative sine of x. And tan of x, derivative 1 on cos squared x. Down here are the ones that are a little bit more complicated that we'll mostly be using. So let's have a look at them. Sine of a function of x, the derivative is cos, a function of x multiplied by the derivative of that function of x. So for example, if we had sine 5x, so sine of the function 5x, the derivative would be cos 5x multiplied by the derivative of the 5x, which is 5. What about cos of a function of x? So say we had cos of x squared. So we've got cos of a function of x, cos function of x. The derivative is negative sine function of x, so that doesn't change, but then we multiply it by the derivative of that function. So it's kind of like the chain rule. And tan, let's say we have tan 2x plus 3. We're going to find the derivative. Well, it's going to be on the bottom cos squared 2x plus 3, and that comes from up here. And on the top, the derivative of the 2x plus 3, which is 2. Okay, so let's do this first question. X sine x. Straight away we can see we've got a product rule. We've got a function multiplied by another function. So u is our x and v is our sine x. u v dash plus v u dash. Okay, so u x times v dash. Well, the derivative of a sine is cosine of x, plus v, which is sine of x, times the derivative of x, which is just 1. So all up, we end up with x cosine x plus sine of x. Right, now this second question needs you to understand how squares work with trig functions. This is the same as writing 4 tan 3x all squared. This is the same, and it's important to be able to separate them because this is an easier way to differentiate. Okay, so we're going to bring that 2 down. I'm using the chain rule here. 4 times 2 is 8. Leave what's inside the bracket. Decrease the power by 1. Now differentiate what's inside the bracket. So I'm going to differentiate tan of 3x. So that's going to be 1 over cos squared 3x. One more step, I now have to differentiate the 3x, which is 3. So let's tidy all this up. I've got 24. I've got tan of 3x on the top. I've got cos squared of 3x on the bottom. Now I'm going to leave my answer like that. You could go one step further and change the tan to sine on cos and end up with sine over cos cubed. Okay, I'd like you to have a practice of these and then come back, check your answers. So derivative of sine is cos x on 2 times by the derivative of that function, which is half, plus 3 sine of x. That's pretty much done. Just tidy up the half. Okay, 3 tan of 2x. So 3 times 1 over cos squared 2x times 2, 6 over cos squared 2x. Good. So I thought I might do a couple of extra questions because some of these can be a bit tricky with trigonometry. So here's one, cos of 2x minus 1. So we're differentiating cos first of all, which gives you sine. Everything inside the function stays the same. Then we differentiate what's inside the function. So this stays the same, then we differentiate it. Okay, over here we've got a product. We've got one function and another function. So the first times the derivative of the second, second derivative of the first. Okay. All right, so we've got sine of x cubed. Now this is not the same as sine of x all cubed. It's different, and that's a really important thing to remember when you're doing these, any kind of maths. So these are not the same. Sine x cubed is this. Sine of x cubed, the x cubed is part of the function of sine. So differentiating, we get cos x cubed. Now, differentiating the x cubed, we get 3x squared. And the last one we'll do is this one. And this is just to remind us of a little trick that's sometimes very handy. When we've got something on the bottom of a fraction, we can bring it to the top with a power of -1. Then I'm just going to differentiate. Bring the power down, decrease the power by 1, differentiate the sine of x, which gives me cosine of x. And we're done.